Hello, welcome to my Calc 1 playlist. In this playlist, we will have 50 to 60 videos covering all the key concepts in introductory calculus. Whether you're just a beginner or you're looking to refresh your skills, these videos were designed to guide you through the essential topics in a clear and structured manner. So what to expect? You should expect fundamental concepts, wrapped together with practical applications and step-by-step tutorials in these videos. Each video will range in length between 10 to 45 minutes. And the structure will be concepts and proofs together, along with example videos, whereby we solved worked examples from start to finish. This way, we gain an underlying knowledge of calculus through theory, and then we apply this knowledge in example problems that you may encounter in your day-to-day basis of a calculus student. For context, the textbook that I'm using is the Calculus 4th edition by Robert A. Adams. I'll leave a link to it in the description if you'd like to follow along. Before we begin our discussion of calculus, I'd like to point out some prerequisite knowledge that might be necessary. It will be important for you to remember some of the key functions you learned in your high school courses, whether that be trigonometric, logarithmic, exponential. These functions come back, and we look more into detail of how these functions change. By doing this, we need to be able to understand a relationship between these functions, understand how to analyze them, and some of their basic natures. You don't have to be a master at functions, but having a good understanding of them is necessary. And to do so, I'm going to present some videos in this playlist that will give you basic understandings of these key functions. Algebra is an important skill for calculus. We'll be going over algebraic manipulation in almost all of our videos. It's a key component of calculus. You don't have to be a master at algebra, and I'll point out some tricks when necessary, but having a good understanding will really grow your capacity for learning calculus. And finally, trigonometry is very important. Understanding how the different identities correlate with each other and understanding trigonometric functions in general will be key in calculus. Like the previous two, you don't need to be a master. However, it's important to have a good understanding of trigonometry. But without further ado, let's begin. Let's start with the motivation of our study. Why do we actually care? What is calculus? In essence, calculus is understanding how things change. Whether that be the path of a planet over time, the fluctuations of the stock market, the speed of which an epidemic spreads, such as coronavirus, we are constantly forced to analyze the relationships among different quantities that change with time. That's the key. They change with time. Algebra and geometry in our previous years were useful tools for describing relationships among static quantities. However, they don't provide enough appropriate descriptions for how quantities change. What do I mean by that? Let's say we want to study the height of a falling rock. Let's say that's our rock. It's initially at height HO, and it falls like this. Let's say that function, h of t, the height of the rock as a function of time, is equal to h0, the initial height, minus 4.9 t squared. This function describes the motion of the falling rock. It tells you where the rock is as a function of time. But what if we want to know the rate of change, the velocity of this rock, how fast this rock is falling? What can we do? Unfortunately, algebra and geometry fall short in this department. They're unable to give us an accurate description. But this is where calculus comes in. Calculus provides us the tools for describing motion quantitatively. It introduces two new operations called differentiation and integration. So let's write that down. Differentiation and integration. So we have this function describing the height of the rock over time, but we want to find out how fast it is falling, the velocity. What we would do is we take the derivative of this function, differentiation, and you'll find in this course that the derivative of this function is denoted as h prime of t equals to negative 9.8 t meters per second. So when we take the derivative of this function of the height of the falling rock, we were able to derive a new function which describes the velocity of the rock at any given time. What if we were to take the integral? Well, if we have this rate of change, this velocity, and we take the integral of this function, it turns out we get this function, the original function, the height of the rock over time. Now, this is key. We can see that differentiation and integration are heavily correlated. That by taking the derivative, we can get the rate of change, and by having the rate of change, we can go back and get the initial distribution or the initial height of the falling rock. Calculus provides us the tools to understand how things change over time, and this is important. This is a tool that opens doors in many areas in advanced mathematics, science, physics, engineering, and economics. And by understanding calculus and rates of changes, we are able to develop a deeper appreciation for the patterns and principles that govern our entire universe. So this is what we're going to be studying. So here's a playlist breakdown. I'm going to cover some of the review of background material in our initial videos. Let's say videos 0 to maybe 10. We'll be covering functions that are needed, important relationships, other things that I find will be necessary for our study of calculus. Then we'll go into a deep dive of limits and continuity, whereby we study how functions change at infinitesimally small distances or intervals. So a limit could be denoted with this form. Limit as, let's say, the value x approaches 0, and we have f of x, and it'd be equal to some value. At the end of this playlist, you'd be able to understand what this means and find out the value of a limit. In differential calculus, we're going to be studying the rates of change, as mentioned previously. This has many applications in many different areas, such as optimization, speed analysis, so many different areas, and it's such a crucial concept to understand. And last but not least, we'll be studying integral calculus, understanding the area under a curve. Let's say we have a function. We want to see the area under A and B. That's what an integral tells us. It gives us this area under the curve. So throughout this course, we'll be studying the different concepts in calculus, and I hope that you'll be able to get a deeper understanding. And without further ado, let's see you in the next video.